Hi, this is Chris, Ashworth at FlexJet. Today we're going to talk a little bit about our machine designs. First of all, our machines are a steel welded frame on our X and Y axis. Whether it is a gantry or a cantilever design like what you see in the images here. They're both X and Y are steel, but our traveling carriage on Y, the Z assembly, is made out of aluminum. Part of the reason for the aluminum is just more environmentally friendly as far as in the environment with water and spray and abrasive and everything getting on it. It tends to hold up better without oxidation and rust. But anyway, our frames are welded steel frames, then they're stress relieved before we machine them to the specs that we desire. And then the assembly takes place here, and these are both long-standing designs. The cantilever design and the gantry design, they've been around for 20, 30 years, actually even longer than that. But with the Waterjets, both have their advantages and disadvantages. The cantilever design is, as you start pushing the limits on speed and accuracy, it's a lot more critical on the mounting areas to get them correct. You also have issues with vibrations and flexing and stuff like that with a cantilever, which tends to make people want to drive them at a much slower speed, which may be why some of the competition runs theirs much slower than we do. With the gantry, you got a lot more rigidity, but you don't have the excess. The biggest advantage to a cantilever design like this is you have access to the table from all three sides of the machine. You're only limited on the back side, which it's easy to work around that. On a gantry, you only have access on the front end or the back end of the machine, and if you're doing a lot of small parts, you tend to do all your work up towards the front of the machine, which long term you can actually have more wear in one area than another. There's ways to compensate for that too, but that's a topic all in itself we'll go over later on. We stick to a two-piece construction design, so that the machine itself is standalone versus the tank. We don't integrate the tank into the machine, and the reasons for this are, like, as the tank changes temperature as you're cutting, it tends to change the shape of your machine. Not any great amount, but it does tend to change the shape of the machine, and this has been proven on numerous occasions using lasers and other measuring devices. So we maintain keeping the tank separate from the machine to allow us to have as accurate of a machine as we can. With regard to drive system, we're using a helical rack and pinion system to drive our X and Y axis. Our Z is on a ball screw. The helical rack and pinion allows us to be just as accurate as a ball screw could be. It depends, you still have to do your engagement, and it's full engagement because of the helical design that we're working with, but it does allow us to get the same type of accuracy that you do with a ball screw. Now, there's plenty of levels of accuracy on ball screws, so it's like if somebody wants to challenge like a double precision ground screw, that's typically in the Waterjet industry, nobody goes to that kind of level. But in the end, we run on a Z-axis a ball screw just for the simplicity of it. And on a three-axis only type machine, you're only using that for positioning the head above the part. On the five-axis machine, the accuracy of the Z becomes a lot more critical. As you start tilting the head, it's got to maintain that standoff properly, or you end up with your parts changing shape compared to what you programmed. Now, one other aspect of our machines is we're using 360-degree bellows on our Y-axis. X sits up on top, as we have here, but we are pressurizing the bellows, and we are pressurizing our Z-axis. We have a rigid bellow design on our Z-axis, which is also pressurized to keep as much debris and abrasive out of the system as possible. Without that kind of protection, the abrasive gets inside there and it can tear up your equipment pretty quickly. Our design is a Teflon sleeve design where they slide into each other. It allows us to be able to replace them and remove them much easier than other designs. Just slide it right over the end and you're good to go, and replacing it is easy. All right, that pretty much fills you in a little bit on our machine designs. Follow next time when we bring back our next FlexJet section.